Mr. Sams, I was watching Ironman Hawaii a couple of weekends ago.
Yeah, it's like the Super Bowl for you triathlete
Oh,
people,
I watched it all day. But an interesting thing happened. Actually, it wasn't this year, but a few years back. Is that the winner of the race, or a guy who was winning the race, he wasn't the winner, as you'll find out. He collapsed during the run. There was two guys, very, very amazing runners, who swam 2.4 miles, biked 112, and now we're in the middle of their marathon. And the guy who'd won the previous year just basically collapsed. Turns out he got kidney stones in the middle of the Ironman triathlon.
Fun.
And I think that has something to do with double replacement reactions.
It does,
kidney
actually,
stones.
yeah.
How do kidney stones work?
Well, kidney stones are calcium oxalates. So what happens is you have calcium ions in your body, lots of them.
Yeah,
okay?
yeah. Bones and such.
Yeah, and your cells need them for all sorts of fun things. And then the oxalate ion, it's kind of a byproduct in a lot of metabolic processes.
Okay.
So actually, if you take too much vitamin C, you can actually build up oxalate ions in your body. And then the oxalate joins with calcium, and it forms this solid precipitate, and then that's what you get is your kidney stones, these calcium oxalate chunks in your kidneys.
So you get these little chunks, and they're inside your kidneys, and that is very, very painful,
and then
I understand.
they got to get out. So
and they have to just come out through the appropriate pipes, and those pipes aren't very wide in their aperture, so
exactly,
it's very painful, I understand. So he didn't finish the race, sadly,
Yikes.
and the other guy won the race. So interesting. So chemistry applies to your life, and that's cool, isn't it?
It is.
All right, cool. Okay, the table, guys, that you're going to want to use that a lot of is this thing called the solubility table. So this should be taped in the back of your comp book or made available. You can print this up, I don't know, whatever. But this is a very important table that you're going to use as we work through.
Yeah. So in the single replacement reactions, you use the activity series of metals table, and the double replacements you use the solubility
now,
table.
in this table, we should kind of make a quick note here. What do each of these symbols represent, Mr. Sims?
AQ is aqueous. That means it's soluble in water.
That means it's not chunky.
Right, it doesn't form a solid.
Okay.
S forms a solid, meaning it will make a precipitate, just like we saw when we demonstrated this in 4.1.
Right.
That yellow solid was a precipitate. NE means it does not exist.
Okay. So that's just three things.
Yeah, and there's an L in here somewhere too, I think, liquid.
Actually, for water right here.
For water.
Actually,
there it is,
In one case, we can make water when you put hydrogen with hydroxide.
Yep.
All right, so the way this works is if I have barium bromide right here in this table, it is an aqueous substance.
Right.
So when you're trying to figure out what the state of matter of a substance,
look it up.
If it's in water, you look it up on the table.
Yeah.
Okay, good. That's not too bad. So, on double replacement reactions, this is the reaction, as you recall, AB plus CD. So you have two couples that go to the dance and they trade partners.
Yep.
Okay. And now, this is the big question is, does the reaction even occur?
Right.
There are three tests that you have to determine whether or not the reaction will take place. First of all, both reactants must be AQ. So reactant A has to be AQ and AQ. If one of them is an S or an E, it does not work.
Right.
Okay, so we're trying to decide. So you kind of have to meet all of these criteria. Number two, at least one product must be S or L.
Okay.
So this product, if this is S and this is AQ,
you're good.
it works.
If they're both AQ, doesn't work.
Right, so if you have a product and it makes an AQ plus another AQ, there is no reaction. You would just write NR. Okay?
Mm-hmm.
And so, yeah. Does that make sense? You could also have, this also could be a liquid. You could also make two solids. That happens very rarely, but it could happen. Okay.
Or liquid and a solid.
Yeah. Now, the key to doing this right, this is tedious, is you must have the scratch pad. Without the scratch pad, you'll make mistakes, and mistakes will cause problems. No, always make a scratch pad. Okay?
Yeah, do it.
All right. No, I'm not even sounding German. That was kind of like Oriental or something.
That was weird.
I don't know. Yeah, well, I'm weird. So, hey, it works. Okay, here is our first example. So, everybody copy these down. Take your time on this, guys. These are hard. Okay? So, let's do this. All right, first thing I'm going to do is a...
Scratch pad.
I think it's a scratch pad, yeah.
But if you do the scratch pad, they're not hard.
Yeah, so I have to then write the ions. I've got Na, and I've got Cl, and I've got Ag, and I've got NO3.
And now we need to apply a charge to them all.
Everybody needs a charge. So I look up in the periodic table, find that sodium has a charge of +1. That's pretty easy. Chloride has a charge of -1. Nitrate has a charge of -1. And silver,
+1.
It's +1. It doesn't say that here. You have to, and it's on the periodic table, it might say it on your periodic table. You probably should put it on there if it isn't. But because nitrate has a charge of -1, you can figure out the silver's charge. So when we rebuild products on the product side, what are you going to make? The sodium is going to get together with the
nitrate, the other anion.
It's not this, Mr. Sams?
No.
Why not?
Because we never put the two positives together. It's always a positive with a negative.
You can't put these together because they both have the same charge. The goal is to have the charge add up to
0.
So the real answer would be Na NO3 and it's positive 1, negative 1. So this is an easy one. There's no weird charge things. Plus AgCl.
Now we need to figure out which of those, if any, forms a solid.
So now let's go look at our table.
So we have sodium nitrate.
So sodium is down here. And then I'm going to find nitrate. You guys can all get your table out. Nitrate.
Right.
Sodium nitrate is right there.
That
looks like it's an
aqueous.
AQ. So I'm going to go back and I'm going to write AQ next to sodium nitrate. AQ. Now I've got to have at least one S or it doesn't work, right?
Right.
All right, so I go back to my table. So I'm going to find silver chloride. Here's silver, silver 1, and then chloride is right here, right? So it's this box, and that looks like it's
solid.
An S. So does that meet our rules?
It does. One of the products formed a solid, so the reaction occurs.
And then we would go back and balance it. Now it turns out this one is just a 1 to 1 to 1. We're not going to spend too much time balancing because you learned how to do that before. So we'll probably balance pretty quickly in these podcasts or in this podcast. Okay, so that's it. All right, let's do another example. All right. So we have iron 3 chloride and ammonium nitrate.
All right. Scratch pad.
Scratch pad, little box. A charge box, maybe. You've got Fe, and then you've got Cl, you've got NH4, and you've got NO3. All right, we'll go back and look at the charges. Oh, iron's charge. I don't know that charge.
Not yet. We'll come back to it.
All right, so let's do chloride. What's the charge of chloride?
-1, always.
-1.
And we have 3 of them, so that's a total of -3.
So shall we do this?
No. I'm just trying to figure out what the charge of iron is.
Why did I not... Wait a second. When I wrote Cl, I didn't write Cl3.
We're not concerned about that. We're just concerned about the individual ions because we're going to go back and balance the equations later.
It's very important, guys. When you write the ions in the charge box, you only write one ion. Do not write multiple ions. Does that make sense? Do not put the 3 there. It's just Cl. And on the periodic table, chloride has a charge of -1.
Right, but since we have 3 in the compound, that means the iron is a +3.
This actually gives us the clue as to the charge of the iron. Since there are 3 chlorides, at each -1, that adds up to -3. That means the charge of the iron is +3. So we need to know that.
There you go.
The nitrate is -1 from the periodic table, and ammonium is a polyion with +1.
Okay.
All right, so let's remake this.
So iron was with chloride, so iron is going to go with nitrate.
Yes, he's going to connect. This is our connection right here. So it'll be Fe. Now we got a +3 and -1, so it'll be NO3 3 plus.
+1 -1.
That's easy. Just put them together. NH4Cl. Now what do we need to do?
Now we need to go look on the table and see if any of those form a solid.
So here's iron 3. And what am I looking for? Nitrate or chloride? Or
nitrate.
Nitrate. Nitrate. Is that right?
Yep.
Okay.
Aqueous.
Aqueous. Okay.
All right. AQ.
All right. So iron 3 nitrate is aqueous. Okay.
And then ammonium chloride.
Ammonium would be at the top. We're pretty close. And then chloride is right
aqueous.
there. Aqueous. Okay. So I go right back here and I write aqueous.
Wait. They're both aqueous.
Aqueous.
No reaction.
Hey, no reaction. We did all that work and we got no reaction.
Yep.
Yeah, too bad, guys. That's how it's done. Okay. If you can figure out how to do this and you see that, oh, they're both aqueous before you do all this mathy stuff,
go for it.
Figure it out. Yeah, it'll save you some work. Okay, let's do another one.
Okay.
All right, potassium phosphate.
Scratch pad.
Scratch pad. I'm going to write K. Do not write K3. It's K. I only write one of them. Now you say, okay,
we didn't
PO4.
balance that last equation, by the way.
We didn't want to balance it because it was
no reaction. Ha ha ha.
All right, now, didn't I just violate my rule? I wrote PO4. I lost the 3, but I didn't lose the 4 when I wrote that down.
PO4 is part of phosphate.
It's a polyion, so this is
a circle.
A circle, if you will, right? And then I've got barium, and I've got chloride. Notice I lost the 2.
Because that's not a polyion.
It's not a polyion. Let's look at the periodic table now. Potassium is charge of?
+1.
+1. Phosphate is -3. Barium is +2 and -1. We don't have to do any figuring on this one, so that wasn't too bad. Now we're going to trade partners. So potassium's going to get together with the chloride. Oh, that's easy. It's 1 and 1.
Yep, KCl.
So it's KCl. Plus
barium phosphate. +2 -3. Got to do the sixth thing.
The 6th thing. So this would be Ba3, PO4, 2. All right, now we'd go and we have to figure out the states of matter. Potassium. Here's potassium. Chloride is here, so it looks like it's an AQ. Aqueous. And the barium phosphate. Here's barium. And phosphate is over here somewhere.
Yep. Hey, it's solid.
It's a solid. So this one's a worker one. This one works.
It happens. Whoops, wrong way.
I went the wrong direction. Barium phosphate is a solid.
Solid.
Okay.
So that reacts.
So this reacts.
Let's balance it.
So we just need to balance it. We got a complex guy here.
Start with that big ugly one.
So
there.
we'll call him a 1. So let's do the barium. So I'll need a 3 here. And I got 2 phosphates, so I'll put a 2 here. That gives me 6 potassium. So that's 6. That gives me 6 chlorides. And hey, look at that.
I have
6
6 chlorides.
That's the answer. Okay, that wasn't too bad. How about if we start with words?
Okay.
A little difficult here.
Let's do it.
All right, we still start with a
Scratch pad.
So I think these are actually easier sometimes. All right, so we've got silver. Silver symbol is Ag. Charge of silver is plus 1. All right, nitrate is
NO3.
NO3
Minus
negative
1.
1. And sodium is Na
plus
plus 1. And carbonate is CO3
Minus 1.
minus 2.
That's what I meant.
Yeah, okay, good. I'm glad you knew it.
I
Now,
know.
in this case, we've got to build the left and the right side.
Yeah.
Okay, so we're going to have to put the silver with the nitrate.
Okay.
So that's going to put the top together. Well, and the charge, oh, they add up. That's pretty.
AgNO3.
That'll be AgNO3. We'll go back and look at the states at the end, I think.
Okay.
And then we'll do sodium carbonate. That'd be
Na2CO3.
Na2CO3, because, of course, the 1 charge and the minus 2 charge. And now we're going to put them diagonally together, right?
Okay.
So silver carbonate would be
2.
Ag2CO3
All right.
plus, over here,
NaNO3.
NO3.
Nano.
So we've got silver nitrate. Okay, so now let's look at our box here. Silver nitrate. Silver was down here. And here's the nitrate column. Okay, so silver nitrate, boom.
Aqueous.
Aqueous. So silver nitrate is aqueous. Sodium carbonate. So sodium is right underneath him. And carbonate is, there we go, aqueous. Okay. Now that's important. They're both aqueous, right? If they're both aqueous, I went the wrong direction there. If they're both aqueous, they've got to both be aqueous to have a reaction take place. And make silver carbonate. So silver carbonate. Oh, there it is. An
Hey,
S.
it's a solid.
Hey, there's our S.
So we have 2 aqueous starting materials and a solid product. That means the reaction occurred.
And then we don't necessarily need to look this up. I will. We don't. It's
aqueous.
aqueous. Trust me. Okay. That reaction is like it's going to happen. Because
Yeah.
AQ makes
Now
SAQ.
Yeah, now we just need to balance.
Now let's need to balance it. Our complex one, I'm kind of thinking it's
probably
that
that
one.
guy, yeah.
So let's make him a 1.
Okay.
So there's 2 silvers, so that
All
means
right.
a 2 here. That gives me 2 nitrates. Okay, I only got 1 over here, so I'm going to put a 2 there. That gives me 2 sodiums. Hey, look at that. I've got 2 sodiums.
Ta-da.
Works. Okay, that's the answer.
Okay.
All right. I think we got a couple more to do.
I think so.
All right, barium, phosphate, and ammonium chloride. All right, start with the box.
Start with the box.
So barium is Ba. Ba plus 2.
Plus 2.
Phosphate is PO4
Minus 3.
minus 3. And then we've got ammonium, NH4
Plus 1.
plus 1. Chloride,
CO minus 1.
minus 1.
All right.
So we're going to put barium together with phosphate. Oh, we get that 2 and 3
2
thing?
and 3,
So
make
that's
up
the
6.
So Ba3, PO4,
2.
2, plus, oh, this is easy, 1 and 1.
Yep.
NH4Cl makes, now we're going to cross them, right?
Yep.
Barium's going to get the chloride, so I'll say BaCl2, because
Okay.
of course the 1 and the negative 2, and they got a 1 and a 3 charge.
Yeah.
So this is a little tricky. NH4,
3.
3, you need 3 NH4s.
PO4.
PO4. Now we should look at the charges,
Yep.
or the states, pardon me.
Yep. So
So
first
we
one,
barium,
barium, phosphate.
phosphate. Here's barium. And phosphate's over here somewhere.
Yep.
That would be this box. So
Oh, ooh.
solid. Okay, so it's a solid.
Yeah,
So we
that's,
go back and write a solid. What's wrong, Mr. Sams?
Well, both of our reactants have to be aqueous.
Oh yeah. Oh wait, if they both have to be aqueous,
No reaction.
we're done.
We're
because
done. Stop there.
Yeah.
Go no further. No
Uh,
reaction.
We could have probably figured that out earlier, and then we could have not written all this out.
We could have.
All right, if you can figure out how to do that and you're smart enough, then go ahead.
Otherwise, go through the process.
Go through the process. That's right. I think we got one more. Let's do one more, Mr. Sams.
All right, last one.
Hey, last one. Okay. Hey, what do we start with?
Scratch pad.
Scratch pad, nickel books.
Mm-hmm.
Iron. So that'd be Fe.
Yeah.
Don't, by the way, I've had a lot of students this year who've said iron is Pb. No, that's lead.
Yes.
They get them mixed up, iron and lead.
Weird.
But anyways, iron is Fe.
Yeah.
All right, Fe, charge,
3.
I don't, I'm looking at the periodic table since I don't see it.
Roman numeral.
Oh, there's a number here. Oh, you're right. There's a 3. That means it's the
Charge.
charge. Oh, good. Plus 3. I'm good. All right. I was a little confused. Chloride is Cl with a charge of negative 1.
Charge.
Okay. Strontium has a charge of. Now, look in the periodic table. You'll discover strontium element number 38 is in column number 2 of the periodic table. So his charge is plus 2.
Charge.
There you go. And hydroxide is H.
No.
No, what is it?
OH.
Oh.
Everybody,
Oh.
yeah, I've had a lot of students this year
Yeah.
putting H for hydroxide.
Yeah. Hydroxide is OH charge -1. Guys.
H is hydride,
Watch that. Okay.
not hydroxide.
Yes. Okay, so let's figure this out. So I'm going to put together, I have iron 3 chloride, so that'll be FeCl3, because when I put these together, I have to get the charge of 0 added up. So, yeah. Plus strontium hydroxide, SrOH2.
No,
What's wrong, Mr.
you need
Sams?
parentheses
Yeah.
around hydroxide.
Guys, a common mistake I see too many times
All
is
the
that
time.
with hydroxide, lots of times, is OH, you need 2 OHs, not 1 O and
Nope.
2 H's.
Nope.
And that's going to, now we're going to trade partners. The iron is now going to get together with the hydroxide. So that'd be Fe, did it make sense?
That was nice.
FeOH3. Notice the parentheses, ladies and gentlemen. Plus SrCl2. I have to play the charge game, 2 and 1, 3 and 1, etc. Now we need to look at our chart, right, to see if this reaction occurs.
Yep.
So we have iron 3. Here's iron 3.
Chloride.
And then chloride is, so we're over here, aqueous.
Aqueous
okay.
it is.
So iron 3 chloride is an AQ.
Yay.
Strontium hydroxide. Strontium is down here. To Sir with Love, an important movie, wasn't it?
Hydroxide.
Aqueous. You see that? Is that right?
Yep.
I got the right box. So, all right, we got two
Hey,
aqueous.
two aqueous, so we have the
That's
potential for a reaction.
potential. Let's see if we can make a reaction. Here's my iron, and we want to put in with hydroxide, which will be right there. Oh, solid. That's the dead giveaway. You make this. By the way, when this is a solid, what do we call that, Mr. Sams?
Precipitate.
This right here is your precipitate PPT.
Pooped.
But, and then strontium chloride.
Wrong way.
I knew that. All right, strontium
Strontium
Chloride.
Aqueous.
aqueous. So that's it works. This reaction is a worker reaction. It's going to happen aqueous. We have one step to go. What would it be?
Balance.
Balance. I see. I'm thinking this is our most complex.
I'm thinking you're right.
So I'm going to put a 1 right there.
Okay.
So I see 3 OHs. And I have 2 OHs.
Ah, we got to do the 6th thing.
Oh, 3 and 2. So 6. Okay, I can't put a 1 there. So
No.
this is wrong.
Yeah.
So I'm going to put a 2 here and a 3 here.
That gives us 6 hydroxides on both sides.
Now
Good.
that gives me 3 SRs. So to fix that, I'm going to put 3 in front here.
Okay.
And now that gives me 6 chlorides. 3 times 2 is 6. And over here I've got 2. I've got 3, so I'll put a 2
for
here.
6.
That gives me 2 irons here. And
Hey,
I come
look,
over
you
here.
have 2.
Oh, and I have 2. Bingo, bingo, done.
Yay.
So, guys, I know this is long and it's kind of tedious. And when you do these worksheets, you'll probably say, this is tedious.
But eventually you're going to be able to do it really fast.
Yes. In fact, you might be able to look at it and just say, oh, I know which one it is.
Yeah.
So, at least you're not an AP. An AP would make you memorize the solubility rules.
Nah.
Memorize this?
Yes.
Yes.
We have
Actually,
we have an easy way to do it.
Yeah, Mr. Neckel knows so. Yeah, but we'll talk about that in AP chemistry when you take it.
Take it next year.
Take it next year, and you'll learn so much more chemistry. You'll just be the smartest person on the planet.
amazing.
Okay, cool.